بعد ما عملت اسمبلي. بالنسبه للاسمبلي باخد بالنا من هنا وانا بركب الاسود ده في السيلفر ده بيبقى فيه زي ميجا درايفر. معظم الكابلات هنا فيها درايفر فخلي بالك. وبالنسبه لدول في النقطه الحمراء دي وخلي بالك ده السنسور ده سي ار بي ام. السنسور ده والسنسور ده حساسين جدا. خلي بالي وانا بركب وانا بشيل. اول حاجه اشيلها هما عشان ابعدهم.
طبعا على بعيد جنب ده.
وانا بركب برضه اخر حاجه كده.
بيس
هو قال لي بتاعت الدايمنشنز.
Now big.
Yeah.
Must be in the center, right?
Around. قلت لك يقول شيء واحد. No. The rotor.
Yes.
We put this on where the general bearings sit. The bearings sit here. Now the general bearings sits here. Here.
Yes.
Around. We measure it. Around.
Not exact.
60.
هو هنا قاس المسافة بين الاتنين بيرنج. مكان البيرنج هنا متعلم اهو.
البيرنج اللي هيقعد هنا وهنا.
هو قاس الاتنين دول طلع 60.
مش بالظبط. هو قال لك يعني
الراوند قاسها وبعد كده قرب المسافة 60 بالظبط. اوكي.
The belt.
تقريبا ظبطنا على اول
الشفط بالظبط. ده شفط ايه ده؟ اسمه ايه ضفت.
It's 11:30.
11:30. By 12, we'll go break.
Who will ask for food?
For food, 11:30.
Who?
This guy,
He's engineer? Engineer?
yeah, long time here, 15 years.
Engineer, that's good.
His salary will
He will speak with
So Yanis?
Mr. Yanis. He will make paraglia for you people.
What?
He will make an order for you people.
He?
He will speak with
Mr. Yanis?
Mr. Yanis, like what this guy did.
Yes, yes. He already spoken to Mr.
He will speak now. Now he will speak now.
على فكرة في حالة تانية سهل. احنا ممكن نلعب الاثنين دول وناخد ناخد شوية. هو أفضل طبعاً.
أنا عايز استنى مش
عشان هو عايز يقوم كده ويرفع على موسيقى.
ده مش الشرط بالظبط. So you want to reach his point in the middle?
Here. Here. What is this?
قلم.
The only one that it's not here. For some kind of reason.
Take Allen 4.
4, but I have no 4 here.
It's not 4.
It's not 4. But I think it's this. Give it a 3. I'm in 3. Lost. We have one. We lost it. Come on. أمان.
Oh my god.
Πήγαινε κάτω ρε να στριμφέρουμε ένα, δύο, τρία τριάρια να μου. Ισχύει αυτό. Πώς το γίνει. Καλημέρα, Κωνσταντίνο.
Γεια σου,
Θα
φίλε.
σου πω τώρα τι γίνεται τώρα. Περισσότερο μαζευόμαστε εδώ το Σάββατο παρά την καθημερινή.
Πιμπίνι was the mean.
What?
Πιμπίνι.
Του
Πίνει.
λέω ότι είμαι πεπίνη.
Τώρα πώς να το πω.
Πες το πεπίνη. Τι είναι το πεπίνη.
Δεν μπορώ να το εξηγήσω.
It's a universal. It has a big pool of things in it. It's from the young girl, Pini, from the beautiful one like me. All these are Pepini. Don't tell them to any. But you should tell him to Adamopoulos. Adamopoulos, tell him you are a big Pepini.
Πιμπίνι.
Big Pepini.
But this one, what does it in English?
In English? I don't know. Υπάρχει και λέξη στα αγγλικά. Υπάρχει λέξη στα αγγλικά το οποίο μας φωτογραφίζουν εντάξει αυτοί. Μας βιντεοσκοπούνε και συζητάμε για το βιβλίο.
Δεν νομίζω να υπάρχει.
Yeah, it's
Only in Greece.
Only in Greece.
yes, only in Greece. I don't know.
It's like a slang. Like slang.
Yeah.
Like nickname.
Nickname.
Yeah, Nick
Not
something.
nickname.
Okay.
How the English use the sweetie.
Sweetie.
Sweetie. It's from call to call someone to sweeten the sugar. Sweetie.
Πιμπίνι.
It's something like that.
That's good. Like ormofoi?
Like what?
Ormofi?
Όμορφη.
Oh, like coffee? Yes, but also it's not in male or female. It's universal.
Πιμπίνι.
Usually ironic for males.
Εσύ πάει η Γαλλία. Άλλη εβδομάδα.
Εγώ.
Ισπανία,
Εγώ.
Ναι.
Όχι.
Α, οκ.
Εγώ τώρα σήμερα πρέπει να βγάλω διαβατήριο. Τι μου λες.
Now you see it's read one time which passes over here. This is a reflective tape. We put it on the rotor. He reads blue.
Yeah.
One. Switch off.
Two.
Blue.
Yeah.
Good.
And measure per minute.
For the RPM. Yes.
Yeah.
Τι τύπος είναι αυτό.
This deflector.
This is reflective tape. We have a lot of it.
Yeah.
Okay. Now it's okay. You have stop. You have locate this.
Yeah.
The belt is in the middle.
Yes.
It measures
RPM
one time per
Rotation.
Rotation.
by one rotation.
per rotation. We're okay. You can make a test drive to see if it's indeed all okay. You see, it's indeed all okay.
So the more you increase it, the more it go faster.
Very good. Well, what I said before, regarding this and the belt. You can, if you have a bigger rotor,
Yes.
bigger shaft, you can put this.
Yeah. To have
For bigger.
a free distance in the
And you have this over here to be more
easy to tighten.
more tight.
بنرفع البتاع دي عشان نربطها دي عند الحاجة عشان نربطها.
Why we want this in the middle around? Because if this was a little over here,
Yeah,
you
I have no
enough,
distance. I
yeah,
have no
you don't
distance.
have enough space to put this.
Yeah.
And now the rotor is small.
Yeah.
We can make a bigger.
Yeah.
The bigger it should be in the middle because here we have no space. We have made a little alternative on that, but that's for us. It's not for you to use it. Okay. That's all about the rotor. That's all about the structure. We set it. We set the rotor. Now, problem.
Software. أنا برضه
You open the PC.
Sorry.
Opa.
Sorry.
دلوقتي كل حاجة تعملها فاضل السوفت وير.
We open the PC.
Okay.
Okay. The program that we use for now, it's this.
Every device have a different program.
No. This program is we cooperate with a company in US and who is software related, and they make the program. Right now, but this is not in-house program. I have talked with Mr. Parsiavopoulos and we decided that we develop a program in-house, and on some point we will stop use this and we will use our program.
Another one.
Yeah, our program, not another one. Our program.
Your program.
Our program.
You mean that
Yeah.
They will create their own program. That's what you say.
Turbomed will
Turbomed.
yeah, will make its own program.
Yeah. But right now we have cooperated with
old
a software engineer in US and they make this program. It's very good and we trust them. But it's not in-house program, it's not our program, it's not Turbomed program. On some point we want to
Check.
to
And
change it.
Develop.
Yeah. That's why for now. Well, you will see this program. Yes? It opens it?
Like any operating system, like Windows and you have
A common laptop.
yeah.
It's a common laptop. It could be your own laptop,
Yeah.
for example. No, it will be industry's Turbomed's, Turbo Suez
Yeah.
laptop, but it's a common laptop. Well, we are here. We put New Balance. We use soft bearing suspensions.
Soft bearing sensors.
Soft bearing suspensions. Soft bearings is this kind of bearings.
Yeah.
Okay.
ده نوع البيرنج.
Two simultaneous planes. Yes. Okay. It opens this. Έρχεσαι να τα ξανακούσεις 21η φορά. It opens this. Here. We put the weight of the rotor.
The weight of the rotor.
Yeah. This rotor weighs 2.85.
How we know the weight?
I measured.
Measure?
Yeah.
Okay.
I put keep it down. That's why I have red over here. 2.85. Counterclockwise and clockwise. It's how we will measure how the
Direction.
program. Yeah. How the program will tell us in where to add or remove mass. Well, we put always this counterclockwise.
Counterclockwise.
I will tell you more about these two things afterwards. Now,
RPM.
add or remove mass. If we want to play with the plastilin, with the plastilini,
Yeah.
you know plastilin university?
Plastilin for kids is
Plastilin for kids.
It's very soft. They use for school to build to
Powder,
make.
like powder.
No, not powder. It's like a clay.
He could grab on.
Yeah, it's like clay.
If you want to check what happens with plastilin, you should put add. If you want to grit plastilin.
It's very soft for.
Like a mud.
Yeah, that's clay. Like a clay. Yeah.
Kids play with it.
Oh, okay.
No. Πήγαινε φέρε μια καινούργια να μαλάκα φέρες την πετωμένη. Λοιπόν,
ده بيقول لك but I am the person who decide add or remove, not the device.
yes,
How?
yes, you will see. You will understand. Plastic.
Okay.
Okay. If you want to put a turbocharger, needs to be removed. Remove material.
Yeah.
If you want to check if what you read it's correct, you play with plastilin. Okay. I will put add right now because we will use this.
Okay.
SBS calibration coefficient is a pre-calibrated coefficient that runs on a specific bearing soft bearings. Yes, calibration. It's this number is
Like, error?
coefficient that I makes it. No error. It means I will explain in how
Sensor.
this electrical sensor passed to the laptop
Yeah.
and makes it in real data.
Like a lag.
Yeah.
Yeah.
This
بتدرب فيه يعني؟
this is determined by me.
Yeah.
It depends on what kind of machine you have worked with.
And each machine have
Yeah.
its coefficient.
Yeah,
But who decided this coefficient?
I decided.
Decide? Okay.
You will use for this machine 0.25.
This number is constant for this machine.
Yeah, for this machine doesn't change.
Yeah. Doesn't change.
كل مكنة المفروض يبقى ليها زي كوفيشن كده بتدرب فيه عشان اجيب الريال
Coefficient is the transfer of data. Like that.
Yeah.
The The lag of the transfer of data from the sensor to the software on laptop.
It's two different numbers. Is 0.25 or 0.32. It's actually the same result, but you can use whatever.
الفيكسز
Yeah.
0.25.
0.25 after some tries I have made, it's maybe better for the 0.32.
يبقى 2.5 زود احسن.
Well, now leave quality aside for now, and we will talk about this. This is how the rotor is put it on the bearings,
Okay.
on the soft bearings. This kind of bearings here, I call it soft bearings.
Soft bearings.
Soft bearing suspensions. That's how they called it. Okay. The red one is the bearings.
Okay.
The black one
This
is the planes that we will add or remove mass.
Yeah.
okay.
Okay.
In this case we will add, right?
Now we will add.
Okay.
Well, now we have two bearings here, one plane here, one plane here.
Okay.
So, from all these possible things, what is the correct? This is the correct.
Yes.
One plane here, one bearings,
Yeah.
two bearings, one plane over here.
Yeah. Opposite.
Alright. Well, here we have some dimensions. Let's put the A. We take
Yeah.
a caliper,
باخد
we
المسافة
measure
دي.
it around.
Not exact.
Around. We don't matter about the exact. Here we have 26.
26.
Yeah. They. 26. Here we have the B. 61. 61. And the C, as we see over here, it's this. 101. 1. That's all for this kind of dimensions. Let's see about the R. Here we see the R of this kind of plane. To measure the R, we measure the place that we will add or remove. We will add or remove here. You see? Yeah. $79, $80, let's say.
No, please again this. I want to measure what?
Where we will
Add.
add or remove mass.
Yeah. In this area.
Let's see where the previous add or remove it is.
The previous.
Yes, this is previous.
Yeah.
This is now. We have made it some days ago. So we measure here. Around.
the thing ده عشان تحط منهم ال
Yeah.
Where we will add or remove.
Yeah.
We have some measure.
Yeah.
Divided by 2. Because we need the R, if you see here. 76 divided by 2, it's 38. 38. Let's go here. Here, this is the balancing place. You see here?
Yeah.
Then move. We measure here. $84, $85.
Divided by 2.
By 2,
42.
42. 42. Okay, now we're going to save this. Test Suez. Save. File saved. All these dimensions, all these things have saved to the machine. This is millimeter or inches.
Okay, we
We
use
measure
millimeters.
Well, now we can press OK and take our first data. We open the tachometer. Tachometer. Tachometer.
Yes.
افتح الزرار اللي
Off. On. And we raise.
You increase it.
Yeah.
This is RPM.
This is RPM. It has 800. 900. It's low. That's a lot. Because well, the RPM that you should put in this machine, it's around from 800 to 1,500. That's the place that
From 800.
from 800 to 1,500. 500.
500.
That's the RPM that you should put
For this
to rotate for balancing.
من 800 RPM ل 2000
Which is the maximum? What is the maximum point here?
A lot. I don't know.
You know the thing?
We haven't tried the maximum.
Because the maximum should be
She will elevate. Okay. Let's try to go over here.
Where is the maximum?
The most logical place to put the it's around 1,100. But the area that you can play, it's to balance for balance reasons. It's 800 to 1,500.
To get the more correct
No,
numbers.
as more RPM you have, the small.
Yeah.
It's not so. Let's say that the more RPM, the slower. That's what we say we have here, but it's not exact.
To make sure of the
You should play over here around
800 and 1500.
400. The logic place it's 1,000 to 1,200.
Yeah.
But in some rotors, you will see that 1,000 is too much. So for safety reasons, 800 is okay. In some light rotors, 800 is too little, 1,000 is too little, you can raise it a little. Okay. Now, to take measurement, you press record. Now we have the mass and angle on plane 1, mass and angle on plane 2.
يعني انا حددت
I
اللي هو
take-
الترباين.
A second measurement just to be sure to explain further. Okay. That's the second measurement. 1, 2, 1, 2. Okay.
We didn't understand the last word.
Yeah. This is the grammar and the angle that you should add or remove mass on the plane 1, and this is the mass and angle that you should put or remove mass according to the program on the plane 2. Okay? Well, I take two measurements.
Okay.
First one is this on the plane 1, and second one is this on the plane 1 again.
Yeah.
First, second on the plane 2. If you
You mean this one? This one?
plane 2 is here.
Okay. Plane one is this one.
Yes, that's why I say
Connection.
To make this 1 and 2.
1 and 2.
Plane 1 and plane 2.
You should be very careful with the plane 1 and plane 2 because
If I
yes, you will never find out what
The
happens.
correct.
Yeah, that's why here is the plane 1, here is the plane 2. As we make the program, here is the plane 1, here is the plane 2.
Okay.
When I put here is the, as I see it, I see the program, here is the plane 1, here is the plane 2.
Okay.
If you mix something, you will find it difficult if you have no experience on it to find out what's happening.
yeah.
And if you don't have an experience, so it will be a little mess because depends on the budget, the sensors, the cables, the program, and what it gets.
Yeah.
So it's okay. I take two measurements. Why? Because we know when a balance machine reads right, we say about the machine when he passes me information about what is happening here. It reads the motor and if this is correct or not. If a balance machine reads right, should have repeatability. Not exact repeatability, but some kind of repeatability. For example, if I read here 0.06 and here 2.5, something is wrong.
Yeah. Yes.
Something is wrong. What is wrong? Something is not tight.
Yeah.
Something is not right in the
Fist
rotor.
way, yeah.
The rotor may has deflection.
Yeah.
I don't know.
Because the difference is big.
Yeah.
Yeah.
That means that for some reason the sensor doesn't read the same thing each time they runs the program.
Yeah.
This happens for some reason. If you don't have repeatability, this means that something occurs on the time that the machine reads, or something is not correct. You should check before do anything. So we take two measurements for that reason. Now I have repeatability.
Because the difference is very little.
Is nothing
Nothing.
because you should understand.
ايه؟
سماحيه يعني قصدي؟
لا اللي هو الثقة يعني ان انت واثق فيه يعني كجهاز.
You should understand that these measurements over here, this mass, how it comes up? It comes up with a signal, electrical signal from here,
Yeah.
and through some mathematics,
Yeah.
makes it to gram and angle. The angle is the same with 2 degrees on this, no problem, and the mass is the same. I need to understand this because this is important. That's why I
Make an explanation.
explained a lot. I will hit you over here.
Okay.
This and this, it was the same. Yes. Maybe in forces, in Newton, it wasn't the same. It was around the same.
Yeah.
This around is for experience. You don't do. You will make balances, and you will understand when this is the same and this data is the same and when it's not.
Okay.
But right now, you should understand that the small difference is okay.
Yeah.
Because how we get this data is through a very complex mathematical models that translates electrical signal to something like mass and angle. It's not the balancing is not exact science. I will leave this and in 2.36 seconds you will hit the ground. I will leave this around 2 seconds we will hit the ground. More or less. I don't know. Okay. He will hit the ground soon.
Yeah.
Soon.
So.
I will go on the 10th floor. I will hit the ground. It will take some time.
Yeah.
It's not exact science. We don't have exact numbers.
Yes, we have around numbers.
Yeah.
Does it do calculations and equations to get the number?
Yeah. The calculation takes some signal, and this results comes from this signal.
Yeah.
This signal is this.
Yeah.
Yes.
Equal.
obviously it will have some
Imbalance.
variance.
variation.
Variation, exactly. Good. This was important. I wanted to understand. The most important it is to understand that balance is not exact science, because the most of the people understand that I see here mass and angle.
It is
Yes, somehow I measure the rotor and I measure the imbalance and I say that it's 0.066 gamma.
Yeah.
No, it's a number that comes up through some mathematics, some mathematics, and it's more or less correct.
yeah.
But in the case with the two writing here are the same. And I checked every part here and it confirms that they are fully tied. The problem in the shaft,
No, maybe.
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 So can how we treat the problem? The shaft.
That's why you need experience.
There is no problem.
If there is a problem in the shaft, you can't do on board, you can't do anything. I will tell you some kind of things that could be a problem. Deflection.
yeah.
I will begin from the rotor. Deflection. Here, a big grammy, a line,
Yeah.
you know, that gets.
That's crush
Need
it.
to be smooth.
No, it's not so smooth.
Yeah.
So it can.
Yeah. Like rust or
He has
Yeah.
imbalance.
So this kind of will pass
Wrong signal.
a
Wrong
wrong
signal.
signal over here that this will translate it to some kind of imbalance which does not exist.
yeah. You need the imbalance, but there is no
There
imbalance.
is no imbalance. Just
just-
that.
Yeah.
Okay. Second, something is not loose. Something is loose. If I open it,
Not,
Will be free.
and go like that, this will translate it.
as an imbalance.
Yeah. Imbalance which will not be stable. Because depends on how we will go up and forth.
That's why before you start anything, you must be sure everything is in order.
Yeah. Yeah. Because if it's not everything in order, I don't mind about the balance. If it's not everything locked, you have something here that rotates with 1000 RPM.
Yeah.
If it goes out, you will be here.
Yeah. Would be
Yeah,
out.
you will be out, exactly. Other thing is here to have some noise. Not noise, noise, signal noise. If this
If it's not
here
well
is not
fixed.
smooth,
Yes.
you can. He will pass a signal over here, and will pass an imbalance over here. You will be able to downsize the unbalance to some level, but from some level and under this level, you will pass an imbalance that you can do anything about it. The balancing, in general, it's a little tough because it's not exact.
Not exact process.
Yeah. In mathematics, you say 1 plus 1 goes 2.
That is calculation.
Yeah, calculation. This
estimation.
1 plus 1. Let's soon we'll see.
But properly, the difference should be little, not much.
Yeah.
Yeah, which is good.
But if it's not, you say let's go for 2 and we will see. But if something is not right, it will not be 2.
Yes.
It will not it will be 1.
B1, yeah.
or 5
And
or 6.
when you understand that something is right, is not right, it will be too.
More than the what you're expecting.
You will be. Θα πολύ αργά. It will be too late.
Yeah.
Because you will grind and you will grind and the rotor will be for scrap. Okay.
Yeah.
But the two reading here may be different, and here may be different too. But the last one here and the last one here must be the same.
Again.
We're talking here two measurements, right? And here two measurements. Here there is difference between the two measurements and the number one, and difference between measurements in number two. But the comparing between 1 and 2 must be the same.
You compare about the plane 1. The difference between 1 and 2.
Yeah.
1 and 2. I don't mind about what happens here and here.
Okay,
The measurements over here and over here, it's separated.
separated.
This is one body and this is other body.
Other body. Yes.
Yeah.
Yes, I take the balancing for each part alone.
Yeah.
Each part, yeah.
Each part alone.
Yeah.
If there's a difference, it's okay. Not between the two parts.
You should separate the rotor.
Okay, okay.
Another thing. Well, though, because as I explained, it's not exact science. It's called dynamic balance because when you change a little this, when I will add or remove mass over here, this will be will be
Effect.
effect.
Yeah.
He will be affected.
Yeah.
So I get this. I will add this here, some mass.
Nice.
I will add 1 gram over here.
Okay.
It's very common. It's very common to raise 0.5 gram over here and 0.3 gram over here, for example. What I mean, what happens to one plane affects the other.
Yeah.
But without any change on the rotor, the prices should be around the same. If I don't put or remove anything, the prices should be the same.
Should be 5.5, not 4.5. Not.
No. The price in here should be 5.5, and here should be 2.2.
Okay.
But the price should be the same.
Yeah. Because I know add and no remove.
Yeah.
When I add,
If I add, I have 5 here. If I add 5, it would go to
1.
2, 1, 1.
Yeah.
This.
The two body.
The one changes the other. That's what I need to understand.
If I add the mass,
If I add the mesh.
Or
If I
remove.
add the mesh.
Or remove. Or
Or move or add, it's the same thing.
you mean that if the software said I must add, for example, 1 gram here.
Yeah.
I add 1 gram here
Yeah.
and make another measurement.
here and
I,
there.
I will see that the other body have a change
Yeah.
like this.
Yeah.
Yeah.
Yeah. This will not be 0.
Yeah.
Will be downsized, but not 0.
Yeah.
It will be from 1 to 0.3.
Yeah.
And this from 0 would be to 0.3.
Yeah.
Let's say that you have 1 and 0.
Yeah.
You put 1 gram over here. You will do this.
Yeah.
You come to the same level.
Not the same level. Not the same level.
Okay.
Different level between them.
Yeah.
0, 1.
Yeah.
You will do this.
Okay.
The one affects the other.
Yeah.
This means that if he want me to add 1 gram here, I can remove 0.5 gram from here and add 0.5 gram here to remove and to make a balance, or
No, you can't. You should remove from here.
add
Add or remove,
Yeah.
whatever it's
Yeah,
in
yeah.
the program. You should do this in here.
Yeah,
From the one.
From the plane that you have the data.
yeah,
But this will affect this also.
yeah. But not wrong effect. Not wrong effect.
Not wrong effect.
Yeah, not wrong. It will affect, but not wrong effect.
Not wrong effect.
Yeah.
He will raise
Yeah.
the imbalance
Yeah.
from this plane.
Just the number will increase, but not wrong.
It's not wrong. The procedure you have followed is not wrong.
Yeah.
But you will downsize this a lot,
Yeah.
and the imbalance of this will upside.
Yeah, yeah,
A little, but upside.
yeah.
Okay. Now, a separate thing. Because you have a turbocharger rotor, then one part will be heavier from the other part. Or the program doesn't understand this difference.
Yeah.
He understands all the body as one rigid body.
One body. Yeah.
Okay. So you will find some rotors that this side weighs a lot, and this side weighs nothing.
Yeah. Really.
Yeah. In this kind of rotors, you will see that even if he says that remove 1 grammar from here or 2 grammar from here, if you remove step by step, not
Once.
step, not by once. Step, if you remove 2.3, let's say, grammar from here, the whole body will be in balance.
Yeah.
Yes.
Because the program doesn't understand that the difference from this mass to this mass is so much.
تمام حاجة مش فاهم خالص. هو ليه حصل ده؟
الجهاز طلع على كده.
بس دي عشان فرق الويت يعني.
مفيش بالانس دلوقتي. تمام.
ماشي
هو الجهاز تعرف تخصيص العربيات؟
ايوه عشان ده كله توتال اللي هو كام؟ 2 و28 صح؟ وعايز يكملها 3 بالظبط عشان يظبط الاوزان.
لا مش عاوز كمان 3 ده وزن الروتور.
ماشي وزن متقسم ازاي؟ هو عايز يوصل الوزن.
الجهاز هو اللي بيعمل كده بقى.
This mass, this one, for the balancing the weight, right?
Yeah.
He told you to add this on here or here, right?
Yeah.
Where
He asked
he add from here.
how the device know weight of plan 1 and weight of plan 2.
the device tell you there is a difference between the weights.
Yeah.
We write the weight
An example,
of all
2
body.
gram here, right? As
Yeah.
example, 2 gram here.
Yeah.
How will you calculate this, the grams?
He calculates as one body.
Okay.
So
After
he calculates that this is not for aluminum, it is from iron.
Yes.
He understands that it's one body.
One body, yes.
Doesn't know that this weights are different from this.
He
Depends on the
he doesn't know.
R. Doesn't know. Depends on the things that you have
You put inside.
in here. In here.
Yes, yes.
R, B, A, C.
Okay, I need this one. I know this one. But it must be balancing in the weights, not to be like this or this.
Yeah.
So if we divided the weights to this side and this side, it must be loose. As example, 1 gram here. So you will add this in this bar. He tell you to add this here, right?
Yeah.
But how can I know this point to add? This one, angle, mass,
Yeah.
0.066 gram.
Yeah.
In plan 1, on this one, right? You will
Yeah,
add-
this one, yes.
You will add the mass here,
Yeah.
0.066, right?
Yeah.
In the other one, you will
0.106.
toxic. You will put here.
Yeah.
Okay, and they started to taking another measurement, 2 measurements here and 2 measurements here.
Yeah.
That's all, right?
Yeah.
Okay.
I tell you the most things that you should know right now because it's a big chapter.
Yeah.
Now I want you to play a little with it to get some experience with it. To do this, I will add mass. I will put remove on program. Remove on program that you made. It's turbo. Where it is? So you find it. To test Suez.
Yes.
Okay. With remove right now. Okay. I will put mass because this rotor is in balance.
Yeah.
As you understand. I will put one more thing. How we understand, he says, in angle 237.
Yeah.
How we understand, what angle is this? 0 is the point that the tape we have.
Okay.
180, you know the side.
Yeah,
side.
yeah, yes.
Well, it's on the other side. Okay. The question is, where is 90? Where is 270?
90.
Down.
No. Wait. هو قصده يمشي كده ولا يمشي كده؟
Exactly.
Yeah.
Count
Clock.
clockwise.
Which I.
Anti-clockwise count.
Well, clockwise. Yes. From plane 1, I explained to all the people 2 methods.
Yeah.
Let's go with the first one.
Yeah.
We take a mass, we put it 90 on 270, and we run the program.
Yeah.
The program should say that at some angle, 90 or 270, you should remove
Yeah.
the mass that you have put.
Yeah.
Okay. Let's go for it.
You put the mass at any position? Not the
You
right
put
position.
90 or 270.
Okay.
Now I have put
Yeah.
over here,
270.
and the program tells me to remove it.
Yeah.
So here is 270.
This means that the direction is 0, 90, 180, and
Good. The first
missing.
way is this.
Yeah. The second.
The second way is as I see the first plane counterclockwise.
Yeah. Which I decided here.
Yeah, which decided here, but not there where you were looking for. It's another where.
Yeah.
It's another place. But counterclockwise everything, and you will find the way. As the plane 1,
I
counterclockwise.
face plane 1.
So, plane 1, counterclockwise, 90, 180, 270.
270. 306.
If you feel okay with this, because what happens here, this is a portable. You will have it all in a bag and you will make it. As you understand, a mix can be happen very easily. So, if you don't feel safe, try with the mask before doing anything. That's the safest method. If you have the experience and you can do it straightforward, plane one, counterclockwise, you will find what it is. Okay.
But your advice the first do the first method.
The thing is that you don't have experience right now.
Yeah.
And the balance machine is very empirical thing. And I don't know.
Complex.
Yeah, it's a little complex. And that's why many, even from this